Hey everyone, and welcome to this talk called Introduction to KubeFlow, how Kubernetes is helping to democratize machine learning and what you can do to help. My name is Chase Christensen, and we'll get more into who I am in a future slide. This is a repeat or an encore talk. I originally did this talk at the Dallas Kubernetes meetup. There was some demand and conversations around, did we have a recording? We did not record it. It was an in-person event. It was phenomenal. We were celebrating the 10th birthday of Kubernetes and talking about kind of the next 10 years of Kubernetes. What does that look like? This is going to be as if I was doing it live, so I might fumble through things, but I'm going to just rip through these slides like you were staring at me in person, and we'll go from there. So before we get into the meat and potatoes here, the guts, who is this guy? Let's get this over with. Let's get started. My name is Chase Christensen. I am not as grumpy as I appear in this picture. This is intentionally satirical. I'm normally a pretty jovial guy. That is me wearing the Let Them Eat Cake shirt at KubeFlow or KubeCon Paris. I was actually at the KubeFlow booth. So if you saw a bearded man flailing his hands talking about the model development lifecycle at the KubeFlow booth, that was me. I'm hopefully going to be at the KubeFlow booth in Utah, so come say, Chase, I heard you ramble about things or took your class. That would be phenomenal, and let's talk about how we can get you involved in KubeFlow. I'm a staff solutions engineer at TileDB, so it's a Series B company, really about how you can get your data ready for a tool like KubeFlow to ingest. So how do you get your data ready so that things that are taking the compute, building models, orchestrating it, can have that data layer ready to go. That's what I do. I work with customers. Before that, I was at an Aricto Series A company. So Aricto was trying to build an enterprise KubeFlow offering, really how we can easily deploy, upgrade, manage KubeFlow at scale. They were behind kind of the movement to making this part of the CNCF. I've been through all of those initial Kubernetes certifications before they were cool and you could be a Kubestronaut, but I think between other academic endeavors, I would love to potentially be a Kubestronaut, so we'll see where the dice land there. I worked at a company called Insight Direct, and they had an infrastructure lab early in my career, so I worked with all sorts of different flavors of Kubernetes. I authored the Introduction to AI ML Toolkits with KubeFlow. It's free. I'll say it again, it's free. You get to learn about model development lifecycle, all sorts of fun stuff, going through the details of what it takes to take your Kubernetes skills and apply them to KubeFlow. It's free. What I do for a living as a solutions engineer, again, is I call myself kind of a technical therapist, i.e. there's all these tools. What do I want to do with them? And I help customers talk through their goals and objectives and then make recommendations on tools. And help make their project successful. So it's a blast. It's half people, half tools and technologies. So it's very fun. Shout out to Ben Ryder. Ben is my multimedia jack of all trades. He's done multimedia or different types of media for all sorts of startups, whether that be video. He's worked behind the scenes in the music industry. He has all sorts of experiences. Honestly, he's worked pretty much every job ever. So he's got a story for everything. He worked on the videos for my KubeFlow course. So if you need multimedia support or you just want to give him a shout out, that is Ben, and that is him about to go to a Red Rocks concert because he's a legend. So what are we doing here? Today's goals. We want to discuss why data makes absolutely everything harder and how that's changing the application landscape. We want to introduce KubeFlow and its advantages. We want to pitch what you as in the person listening right now, hopefully, this is tailored to someone, since this was at a Kubernetes Dallas meetup, someone who has a lot of Kubernetes skills and is hearing a lot about all these AI things and saying, well, where do I land in it? Am I just in charge of provisioning GPUs, or is there a world where I'm doing more infrastructure-like things, but maybe with software? We're going to discuss how to get started. If this proposal of what's the next 10 years of Kubernetes look like, well, maybe it's being a machine learning engineer that really understands Kubernetes. And we're going to provide additional resources and potentially some swag. So we have a survey that's open. You can fill in some details about what you'd like to get involved. We're not going to contact you if you don't want to. I did not tell Amber, who's in charge of sending t-shirts, about this. So, we'll figure it out. We'll get you some KubeFlow stuff. Let's talk machine learning. So machine learning is everywhere. When I do this live, I open this up to the audience and say, well, who's got a machine learning project? And everyone raises their hand. And the question then becomes, well, who's got a machine learning project that's profitable, that they're proud of, or that's doing something? And it's really a lot like where the cloud was, where everyone was just moving to the cloud, or Kubernetes, everyone was just moving to Kubernetes because Kubernetes is cool. But the question now is, how do you get an outcome, and what tools do you use? Because in the end, you want your machine learning to be doing something, whether that's RAG and it's a search, or whether that's, maybe it's a recommendation engine, leading to a business outcome, leading to revenue, leading to us all getting paid. But still, machine learning is absolutely everywhere. And that's because data is everywhere. And we have more data than ever. So how do we sift through this data? And then how do we take actions on these data with historical context, whether that's cultural data, transport data, all these other datas here? Each of these have a different format. Each of these have a different insights and different ways to read these insights. It's really complicated, but we want to be able to harness this data and autonomously make decisions. And not even Kubernetes is safe. If you thought that your job was safe from AI, well, Robusta, shout out Robusta, has news for you. Robusta is trying to say, can we make a virtual site reliability engineer that can take in events, alerts, or whatever, apply the network, the matrix, the mind meld of the internet of different SREs, posting responses, etc., use that as an LLM and try to root cause things with AI. So this is a really interesting experiment, and we'll see how much success they have with actually reducing the mean time to repair for applications. And because data and machine learning are everywhere, we are now responsible to deploy applications that are no longer just an application. It's not just a database. It's not just something that's, I'm processing a sale. I click a button, it goes in my cart. It goes in my cart, it goes into some shipping. Like all these really complex things. Well, now we have a model, a brain that's running the show here. And that brain is the model that's taking in the data, which we're saying is the blood. It's the life force of our application, of our application, which is going to be the body here. It's cleaned by our data engineers. And then the application, based on the brain's predictions, does something. This is something we do every day, right? Think of crossing the road. You're constantly saying, oh, look, I'm processing maybe this image data and historical data, like, oh, there's a truck coming. I know my legs can only go so far. Should I cross the road or should I chill and wait? Well, what you're doing is you're taking in data and then you're telling your body to take an action based on that data. Well, now our applications are doing that. They're no longer, and by the way, it's a model and an application. Sometimes they're embedded, but they can be separate as well. And that's adding, again, this data layer, these data and data engineers, where I have to now have clean data for my model. Otherwise, I'm giving my brain dirty blood. And because of this, because now it takes all these different, I mentioned data engineers, all these different levels of expertise, our teams are no longer just dev and ops. We have a data scientist who might be throwing a Jupyter notebook. I've seen this. I've literally seen this. I've seen a data engineer or a data scientist just like throw a machine learning Jupyter notebook, like a machine learning code in Jupyter notebook over to an ML engineer and say, make this scale, fail, and all the things that if we're talking to a Kubernetes software audience, we all know is important for software. And we just did this with developers. We just helped developers say, hey man, how does your code run in high levels of parallelism? How does your code scale? How do we deploy your code? So DevOps, dev and ops just kind of have learned to get along with different technologies such as containers. But now there's a data scientist for the very usually statistical academic background throwing a notebook to an ML engineer who's then saying, well, how do we make this actual software? Working with maybe a developer developing an application, and then eventually an operations team, whatever that looks like, that's in charge of deploying, holding the pager, etc. So our teams are getting more complex than ever. And I just hit on all these different personas. And remember, all of these decisions that this application could be making map to a model outcome. So if your machine learning model says the tickets are cheaper because of some prediction, and the application puts a cheaper ticket in front of a user and they buy that ticket, well, if we took that ticket at a loss, Now your business stakeholder is upset. Your business stakeholder says, well, I need to know what this model is going to do. I need to know what this application is going to do. The end user needs to be aware of this application. The data scientist has to be doing the data. The manager has to be running the teams. The data engineers have to be cleaning the models. The product manager needs to be making sure it's properly resourced. And of course, operations need to be performing based on our goals, usually subject to the machine learning engineers as well as the business stakeholders. So all of these teams, all these personas in these teams, and I left out personas, and these are not prescriptive. Different teams look differently based on where you are in your company's journey. If you have enough resources to hire individuals, or sometimes you'll see we're all wearing different hats and it gets really complicated. And really we're trying to build models to create value. And all of these steps could be different personas. And this is a loop, right? We retire a model, but with the retired model from the ashes rises a new model. And of course, we know that defining a problem never ends. That's why we're in business. Businesses are subject to entropy, just like code. If codes just sit around and doesn't do anything new, it's not going to be very useful because the world around us changes. So we have to constantly be defining problems and looking at the problems. And sometimes those problems can change context and we get model drift, etc. But the point is we're constantly defining these problems, putting models in, and taking models out as the business evolves. And this is complicated. And this is requiring new testing and development practices. This is this conversation of reproducibility versus replicability. And this starts a crusade. I was actually just talking to some engineers from TauDB, and they're really involved in the R project. There's like reproducibility, replicability. It's hard, it's a dream. And that's true. It's very complicated because not only do I need to just deploy the same application, but to validate that this application is doing what it's supposed to do, I need to give you the data that I use to train the application, and I need to use the data that I use to test the application, and then we need to subject this application to new data. Just like when you're training, let's just say like a sales engineer or a sales professional, you're not training them to qualify the flashcards, right? Not to qualify the users that your product might fit. You're not going to say, well, I've seen this already. You want them to kind of have a familiarity, but the goal is to have them meet new customers, new potential customers, and say, hey, we can help you, or hey, we might not be a fit. So being able to take new data, i.e. new people, and apply the old learnings, the sales training to those new people, we need to be able to do both, just like our applications. But the complexity of traditional applications, quote unquote traditional, right? It's not like we're using wood here and tweed, but how does our application scale? How does it fail? All these things about latency and response times. How does it all align to our business goal? How do we handle maintenance? How do we make sure that we have the velocity to address the changing worlds outside? How can we make sure that our developers aren't deploying something that's risky to the business without knowing? And how can we also make sure that we're not stopping our developers from doing anything because they're so afraid to do anything because we've created a pile of gates for them? So what's the plan? This is my doom and gloom slide because we've all been through this with Kubernetes. We've all seen the massive CNCF nightmare landscape. And these are amazing tools. Don't get me wrong, none of these tools are bad. Well, none of these tools that I know of are bad and bad subject, but these tools are great. These have smart people behind them. They're doing interesting things. But these are a lot of decisions, and there's a lot of overlap, and this is a lot of maintenance. This is a lot of complexity. How do you handle this all? Well, introducing KubeFlow. Brief history. KubeFlow started from Google's internal approach to operating TensorFlow. Project was open sourced in 2017. It was recently donated to the CNCF. It takes all these concepts we talked about previously. What do you need to do to be part of a DevOps team? All these things of applications. Well, how do we apply that to MLOps? And if you talk to some of the early KubeFlow engineers, they say, well, this is where we realized there needs to be a rise of an MLOps engineer who understands how to talk to data scientists, who understands the nature of these applications we're calling models, and the algorithms behind them and how these algorithms themselves scale and fail. So now we have a DevOps engineer. Well, we also need an MLOps engineer because it's this new type of application. We need to understand how to deploy it and harden it and all those fun things. So KubeFlow became an MLOps toolkit, but more than that, it's an ecosystem. It's giving all sorts of integrations coming in through the community that help you understand from those giant CNCF landscape what's a minimum deployment to do some successful common machine learning development patterns using tools. So I often say, well, and I'll show you a different slide around this, upstream to KubeFlow, who are KubeFlow's customers? Well, in my mind, my customers as someone in the KubeFlow community would be the newly adopted Spark operator. How can we make it so that the Spark operator whose customers are people using Spark, how can we make sure that people using Spark have the best possible experience using Spark, and how can we help support the Spark operator who wants to do so? How can we make sure that there's a full story so that the Spark operator is incredibly valuable because the people using Spark are getting a lot of value out of it, and therefore KubeFlow is more valuable. And we do this with PyTorch, we do this with XGBoost, all these different tools. KubeFlow helps say, let's make an integrated ecosystem where we're all talking the same language. And we're attacking this from more than just one angle. I'm probably missing some here. In fact, I'm actually missing TensorFlow in a few spots, so that's not the best. But look at all these different applications from the CN AI landscape that we have worked with. And this is either as a first class, deeply integrated in the community solution, or something that we've worked with the community to integrate in kind of a one and done, which is no problem, or something that's maybe been a new conversation, such as how to get Feast, right? Feast had this big conversation of what is Feast, what's the future of Feast, how does that integrate into KubeFlow? Volcano is a great solution, PyTorch, all these great things. How does it work with KubeFlow, and how can we come at all sorts of different problems within the KubeFlow ecosystem so it's not just one size fits all, it can be composable. And this is where we find KubeFlow's technical advantages. We have a complex management that's supposed to be production ready, right? It is production ready. It is all these engineers saying, what does my production look like? So that you have the enterprise non-negotiables. If you don't have authentication, we've got problems. If you don't have isolation for users, we have problems. So what do the enterprises need? And the community comes and people come to us from the community and say, well, this is what my enterprise need. And we go out and we target them based on what we believe are non-negotiables. And this is where you have like the security working group, right? Managing these things that we know can risk our users. Well, how do we solve that so that someone can deploy this in production? We're flexible and neutral. We're the CNCF donated, so we're part of the CNCF. Not only that, but because we're part of the CNCF, going back to my previous slide, we can play nice with more and more CNCF projects because we have that common understanding together. And we have that neutral party we work within. And that's where you can see these communities and integrations. Going back to that previous slide. Here's another perspective, and this is what I was talking about when you think of who am I in service of? Well, I'm in service of PyTorch, TensorFlow, Jupyter Notebooks, all these great things that KubeFlow wants to run, people doing machine learning pipelines, and I'm sitting on top of this infrastructure. So a lot of the infrastructure says, how can I run Kubernetes really well? Well, then how can I deploy KubeFlow on your version of Kubernetes so more people are using Kubernetes? Because more people are using Kubernetes, KubeFlow is an amazing fit, and because KubeFlow is an amazing fit, in the end, people want to use PyTorch, TensorFlow, Hugging Face. We're all winning together. We're all providing value in our different layers. Again, KubeFlow being that centerpiece. And we leverage these Kubernetes patterns that we know work really well for all sorts of traditional applications. So these are these framework agnostic job submissions, simplified resource management, and then how can we efficiently schedule and use resources? A great example of this is the training operator. This is very high level, and we can have a longer conversation around the training operator. But how can I use a YAML manifest and just change a few things within the same operator to deploy different types of training jobs? Again, using that operator pattern, which is a pattern we know and love. This is from the CNCF white paper. You can do this, but with machine learning training jobs. But we have more than just a technical advantage. I've hit it on a few times here, but we have community-driven expertise. Knowing how to build is phenomenal, and we have really great engineers knowing how to build things. But knowing what to build and defending the why behind the what, that's where the community comes in. We have specialized working groups that do this professionally and that are now within the community making it better. We're leading to a widespread adoption and impact as the CNCF is launching white papers and saying, hey, the future of ML is on Kubernetes. And again, we're still natural and open, neutral and open. You can come and contribute if you want. No one besides a foundation really owns KubeFlow, and that foundation has no interest in locking down KubeFlow. It actually wants to bring in distributions and contributions. So this is where we say we're building a democratized solution for machine learning AI. So what about you? What about you as a Kubernetes expert? What's the point here? Like, how do you fit into this? Well, as we hit upon, MLOps does need DevOps. We still need these DevOps skills for machine learning, whether that be reproducibly containerizing a model or deploying Kserve or hardening a Jupyter notebook and submitting it to a build process or providing a way to again, build code into something that can be shared. You can enhance MLOps with DevOps tools. You can use things like GitLab or other scanning tools if you want to make sure that there's low vulnerabilities, or GitLab for building. And you can continue to say these network monitoring tools and these other monitoring tools, these CPU, etc., like these are all applications in the end. How can we help improve the reliability and scalability, even if that means we need to tweak the algorithms, retrain the model? At least these tools that you guys have been doing day in and day out for other applications, how can we apply those to machine learning models? Because the complexity of, again, traditional infrastructure didn't go away. All of these things on this slide, and these are things we've talked about and you all understand, and you look at something like Volcano, which is just a Kubernetes native batch system that can do topology-aware scheduling and how to prevent gridlock. This is still hard, and these services themselves, right, they still need to be run by someone, and storage and networking, this all needs to be attached alongside the complex data application that is a machine learning model. This is one of my favorite Kelsey Hightower quotes. I really like the end here where he says, we're talking about the difference between making a movie and filming your child's birthday. These aren't the same things. And this kind of hits me pretty close because I'm a sales engineer, so I'm really good at solutions engineering and building a quick prototype. But taking that prototype and hardening it and bringing it into the real world is really complicated and really risky. You need to protect your user data. You need to protect your company from being attacked, all these different things. But right now, we're deploying machine learning models on Kubernetes because machine learning models benefit from a lot of the beautiful things that Kubernetes does, such as that agnostic, the job submission, the ability to reschedule services, the ability to have that authentication, authorization, mutual exposing, all these amazing things that Kubernetes does. But that's still complicated. And just saying, well, I want to leapfrog all that and just become a machine learning engineer, and I guess I'm going to run on Kubernetes. Well, you still need Kubernetes people because Kubernetes people are also infrastructure people, and these infrastructure people are working with software people, and this is all very important. And kind of talking to what we saw with the wall of confusion, I've actually seen this from data science teams. Can I just throw my notebook in production? And actually, I think people do have notebooks in production. There's some great tools that can do this, but this is kind of the common joke I see is just a bunch of cells and, hey, can this be a model now? And I'm sure we all feel like this, and this is at least how I feel. It's another day, another ops. We did DevOps, there's FinOps, there's SecOps, there's all sorts of opses. In fact, I feel like there's another ops every day. But I believe that this ops is the one that's going to win out and is the most beneficial to your career, because the next 10 years of Kubernetes and our careers are going to be about understanding how to deploy these data-centric applications. And that's what the CNCF AI working group is here to really pave the way with. So let's talk about how you can get involved, hopefully believing my thesis here. You can join us on the official KubeFlow documentation. There's some really great docs out there. /contributing will help you contribute. You can contact me directly, christensenc3526 at Gmail. You can contact Amber, who's another user within the KubeFlow community that helps people get involved, akgrainer at Gmail. Josh Bottom is an original gangster when it comes to all things KubeFlow. Josh Bottom will help you get involved as well. Or you can say hi at KubeFlow Summit. We'll be at KubeCon NA. Let's let our powers combine here and make an amazing solution for machine learning going forward. Here's some more resources to learn more, kubeflow.org. some playlists on the official KubeFlow YouTube channel. The LinkedIn for KubeFlow has a lot of great announcements and references to the blog posts. My course that was launched, that's again free, so you can help yourself get started and do some example workflows on KubeFlow. And we are moving to the CNCF Slack, so feel free to ask questions there. This is the link to the survey, and hopefully you can answer our survey, get involved, and maybe even get some swag. I know that was a lot. I feel like I need to throw my phone down. I don't even want to look at how much time this was, but I appreciate everyone who stuck around. Even if you had to digest this in 1,000 different little mini pieces, that's why it's on video. That's great. But I appreciate for you taking the time, and I hope to get you involved in KubeFlow. Thanks, everyone.